Okay, so in chapter 2, chapter 1 we took a look at what data is and types of data and some definitions. Now we're really going to dig into what do you do now that you have some data. And one of the most basic things to do is kind of put it in piles, organize it. So some things that we look for in data, characteristics, the center of data, so we want to know where the middle is. Variation, how much do the values, I would say vary, but we don't want to use the same word twice. So how much do the data values, we'll use differ. Distribution, what is the nature or shape or spread of the data? Is it bell-shaped, which would look like something like this? Is it uniform? Again, we'll talk a little bit more about uniform distributions, but this is what a uniform distribution would look like. Or is the data skewed to the left or skewed to the right? A distribution like this is skewed to the right. We'll go over this later. And this would look like distribution that has data skewed to the left. Outliers. Do any of the data values lie far away or far from most of the other data values? So if you think about things like, let's say, heights, if you have somebody who's very, very tall, like Shaquille O'Neal or something, they would be an outlier, correct? Finally, how does the data change over time? One comment I want to make about this is time will always be graphed on the horizontal or x-axis. Because when you think about things, we might track, populations over time or temperatures over time, and you might see something like that. But this horizontal axis is always time. All right, so now we're going to dig into frequency distribution tables, meaning how do we organize this stuff? So I have some data, the number of hours my classmates spent playing video games on weekends. So there's the data right there. The purpose of a frequency distribution is to organize the data to help us understand the shape. And we're going to see when we get these charts built, you'll be able to see the shape of the data. So it's going to be organize the data to help us understand the shape. Okay, one of the definitions we need to have to be able to build a frequency distribution table is we need to understand what the range of a data set is. So the range is the maximum minus the minimum, or the biggest number subtracted from, or the smallest number subtracted from the biggest number. So when I think about something like ages, it would be the oldest person's age minus the youngest person's age. In this case, we're going to look at the number of hours that my classmates spent playing video games on the weekend. And I can see what we have right here. I think 24 seems to be the maximum value. And then I look around, the minimum value is actually 0. So to find the range, we're going to do 24 minus 0, which is, I don't think I need a calculator for that. The range of this data set is 24. So now that I know I have a range of 24 to cover, what we're going to do is we're going to figure out where do my numbers stop and start. So in a frequency distribution table, classes are intervals of numbers. The number of classes you have can range depending on the type of data set you're working with, but it's usually somewhere between 5 and, I don't know, say 12. This is very general. You'll see that there are times we don't want just 1 or 2 different classes, but you also don't want 20. Again, in our class, for our purposes of our course, I will always tell you how many classes to use. So now we're going to learn how wide we need to make these classes. So what we're going to do is we're going to take the range, and then we're just going to chop that range up into the number of classes we have. And how do we chop it up? You use division. So up here, we found that the range was 24. So we're going to do 24 divided by, it says right here that we are going to go with 5 classes. So we're going to do 24 divided by 5. And I'm just going to use my calculator. 24 divided by 5 is 4.8. So that means the width of this should be something like 4.8. but I don't really want to count by 4.8s, do you? So most of the time, it doesn't matter what this net back number is. If you get a decimal, we're going to round up to 5. Okay, so we need to make these 5 wide. So we're going to go down, and it says create the classes. So we're just going to come up with the numbers that our classes have. So where does this start? So actually, take a look at our data set. It's recopied down here. And you can see that my smallest number is 0, right? So that's where we're going to be starting. So we're going to start at 0. And we want a width of 5. Now be careful. You don't want to add 5 across, and I will show you why. If you go from 0 to 5, if you count that, we got to count 0, right? So it's 0, 1, 2, 3, 4, 5. Is that a width of 5? No, that's a width of 6. So this is no good. So we're actually going to add 5 down. So 0 plus 5 is 5. 5 plus 5 is 10. 10 plus 5 is 15. 15 plus 5 is 20. Okay. So you can see that these are the first numbers in our frequency distribution table. Now, how do I find the number previously? Usually what you do is just count backwards. So you might say, I count back to 4. But we got to be careful, because what about a number like 4.75? We certainly have decimals in our data set, you can see down here. So we're actually not going to go back to 4, but we're going to go to 4.99. Why did I use 2 decimals? Because my data set has 2 decimals in it in places. So I go out the number of decimals equal to how many my data set has. And now we're going to count back, or actually we're going to do the add 5 thing this way as well. You can count back, but it's a little bit easier just to add 5, which will give me 9.99, and then 14.99, and then 19.99, and then 24.99. So you can see here, these are my ranges that are going to go into my frequency distribution table below. Again, I haven't even shown you a picture of it, but you'll see, I think a lot of people are familiar with these. These may be new to you, but they're not too bad. So now we're going to recopy those numbers in here. I'm going to hit pause on the video right now, but again, we're just going to take those numbers and bring them into the class limits. Okay, so again, it's much neater to see typing, so I went ahead and recopied those in and just typed those in. Hopefully you brought those down into your notes as well. All right, the next step's not the most exciting one, but it is one of the most important ones. What we're going to do is we're going to take our data set over here, and I'm going to think, okay, just a second. I'm going to say, okay, that first number, 9.95, where is that going to fit over here in terms of these classes? So this first number, it's going to be 9.95 would fall right here, right? And what I'm going to do is I'm going to then cross this number out, and I'm going to go down to the next one. Now, there's lots of different strategies to be able to do this, but you want to use the one that works best for you. I think going just one by one tends to be the most accurate. I see a lot of people make a lot of mistakes, and so this is just the way that I would recommend going through this. I'm going to hit pause on the video. I'd like you to take a second, hit pause as well. And why don't you go through and organize these numbers? Make sure you get it right, and then you can go ahead and hit play on the video again and check to see if you got what I got. All right, so I got my numbers all tallied up. This does not look great, but now I'm going to copy the actual numbers in here. So I got 3, 3, 4, 7, and 8. Again, I cannot stress enough, please take your time doing this, because if you screw this step up, then I'm about to show you a bunch of other stuff we're going to do based off of this. So getting this data organized here is one of the most important steps. So again, please take your time. You can take a look and see. Now we got a kind of a sense of the shape of the data. You know, not a lot in these lower frequencies, and then they really start to pick up towards the higher ones. So I'm going to stop the video here. We're right about 10 minutes, but in the next video I'm going to be taking a look at a couple different types of frequency distributions, some variations on this one we have built now. We will use these, but the other ones are relative and cumulative frequencies, and then we'll start doing some visual representations.